Boyle's Law. Robert Boyle was a scientist who studied the effect of pressure on the volume of fixed mass of a gas at constant temperature. So, this law states that at constant temperature the volume of the given mass of a gas, volume of the given mass of a gas is inversely proportional to its pressure. Okay, is inversely proportional to its pressure. Okay. This law is called as Boyle's law. Okay. Now, mathematically we can represent this as V is inversely proportional to pressure. Okay. So, V is inversely proportional to pressure at constant temperature for given mass of a gas. Constant temperature for given mass of gas. Okay. So, V is equal to K. A proportional K is called as the proportionality constant into 1 by P, or we can write PV is equal to a constant, where K is called as the proportionality constant. K is the proportionality constant. K is the proportionality constant and it depends upon the amount of gas and temperature. Okay. So, at constant temperature for given mass of the gas, V is inversely proportional to the pressure, or we can write V is equal to K into 1 by P, where K is the proportionality constant. Okay. According to Boyle's law, we know PV is equal to a constant. Okay, or we can denote as constant means K. K is the proportionality constant. Now, let V1 and P1 are the initial volume and initial pressure of a gas. Initial pressure. Okay. On expansion, volume changes to V2 and pressure changes to P2. Okay, so first volume is V1 and pressure is P1. This is the initial volume and pressure. On expansion, the gas changes its volume to V2 and pressure to P2. So according to Boyle's law, we can write P1 V1 is equal to P2 V2. Okay, using this equation we can calculate the values. If P1, V1 and P2 are known, we can calculate V2. Like this, any of these values can be calculated if all the other three values are known. So, using this equation, we can do solutions. Okay. Now, there is a relation between pressure and density also. Using this Boyle's law, we can introduce a relation. Okay. Now, we know density is equal to mass by volume. Okay, density equal mass by volume, and from this Boyle's law we know PV equals a constant. Okay, or we can write P is equal to K by V. Okay, so instead of 1 by V, we can write 1 by V is equal to P by K. So this will be equal to, from this equation, M into P by K. Okay, so M by K is a constant into P. So this is another constant. So this is equal to K1P. K1 is a constant. Okay, so from this we can see that D is proportional to pressure. So D is proportional to pressure. So at constant temperature, density is directly proportional to pressure. Okay, this is another relationship between density and pressure from Boyle's law. Graphical representation of Boyle's law. First graph P versus V, and the second graph P versus 1 by V, and the third graph PV versus P. Here P versus V at different temperatures are drawn. Okay, so at constant temperature these curves are also called as isotherms. So highest curve represents the curve at high temperature. Okay, now next in the next graph P versus 1 by V, and straight lines are obtained, and these straight lines are passed through origin, and here T3 greater than T2, which is greater than T1. From this graph we can see that at higher pressures the gas deviates from Boyle's law. Gas deviates from Boyle's law. Now third graph T2 represents the highest curve. T2 is greater than T1. So at high temperature highest curve is obtained. So these are the different graphical representation of Boyle's law, and gases are highly compressible also. Okay. Next, an important application of Boyle's law. That is, mountaineers have to carry oxygen cylinders with them in the case of emergency to restore normal breathing. Okay. This is because according to Boyle's law, density is proportional to pressure. Okay. So at sea level air is denser. Okay. As the altitude increases, what happens? Altitude increases, air pressure decreases. Okay, air pressure decreases. So mountaineers, when they move up, the air becomes less dense. Okay, at the top the air becomes less dense. That means less oxygen molecules are there in the small volume. So in a small volume the oxygen density will be less, so less oxygen molecules will be available for a small volume. So in such cases the oxygen is insufficient for breathing. Oxygen is insufficient for breathing. So in such cases they are using oxygen cylinders. Okay, this is the important application of Boyle's law. Question: a sample of gas occupies 100 liter at 1 bar pressure and at 0 degrees Celsius. What additional pressure required to reduce gas volume to 5 liter at same temperature? So at constant temperature the reaction is taking place. So according to Boyle's law, we know P1 V1 is equal to P2 V2. Okay, so at constant temperature P is inversely proportional to V. So P1 is given 1 bar, then V1 100 liter. Okay, so first we have to find P2. V2 is also given 5 liter. So P2 will be equal to 1 into 100 by 5. So answer will be 20 bar. Question is the pressure required to reduce, the additional pressure required. Okay, so first 1 bar it gets changes into 20 bar. So the additional pressure required will be the difference between these two. So additional pressure required will be equal to 20 minus 1 bar, that is equal to 19 bar. Okay.